Good morning. Hi everybody. I am Dr. S. Julius Jaisingh, Professor in the Mechanical Engineering Department, Loyola Institute of Technology and Science, Thovalai, Nagarkoil. Today I am going to brief about the projection of solids in the subject Engineering Graphics. So, the learning outcome of this subject, we are dealing with a lot of solids every day, like cone, pyramid, prism, cylinder, cube, sphere, etc. When a solid is given in space with respect to some reference plane, HV, horizontal plane, vertical plane, profile plane, or reference axis, so we have to draw the front view, top view, or any other one of the side view. So to project or to draw the front view, top view, and any one of the side view of a given solid in given position is the learning object or learning outcomes expected from this topic. So let me say something about solids. What are solids? A 3D object having length, breadth, and thickness and bounded by surfaces which may be either plane or curved or combination of the two. What are the different types of solids? The solids may be mainly classified into two. One is polyhedron and solids of revolution. What are regular polyhedron? A solid bounded only by plane surfaces or faces. Its faces are formed by regular polygons of same size and all dihedral angles are equal to one another. All the sides are equal and all the angles are equal. That is called a regular polygon. The other polyhedra, when faces of a polyhedron are not formed by equal identical faces, they may be classified into prisms and pyramids. Projection of solids, by definition, it can be defined as finding the front view and top view and side view of a given solid in a given condition. Overview of my presentation, we are going to describe what are the types of solids, then projection of solids in symbol position. With respect to symbol position, three different conditions: the axis of the solids to the perpendicular to the HV, the axis of the solids perpendicular to the VP or vertical plane, the axis of the solid parallel to both the horizontal plane and vertical plane and perpendicular to the PP or profile plane. The third condition, projections of solids with the axis inclined to one of the reference plane and parallel to the other. So two conditions under this heading: the axis to the vertical plane, the axis inclined to the vertical plane and parallel to the horizontal plane. And second one, the axis inclined to the horizontal plane and parallel to the vertical plane. The fourth condition, the projections of solids with the axis inclined to both HV and VP. The types of engineering solids. The solids may be divided into two main groups. One is polyhedra. Under polyhedra we can define 7 types, and solids of revolution. Under solids of revolution we can consider 2 types of solids. What are 5 regular polyhedra? First one is tetrahedron. The tetrahedron is having 4 equal equilateral triangular faces. Cube or hexagon. What is cube or hexagon? A solid bounded with 6 equal square faces. Then octahedron. Octahedron is a solid bounded by 8 equal triangular faces. Then dodecahedron, a solid bounded with 12 equal regular pentagonal faces. Pentagon means 5 equal faces, 5 equal edges and 5 equal inverted angle. A solid bounded with 12 equal regular pentagonal faces called dodecahedron. Then icosahedron, a solid bounded with 20 equal and equilateral triangular faces. Then what are polyhedra? By definition, a polyhedra is defined as a solid bounded by planes called faces. When all the faces are equal and regular, the polyhedra is said to be regular, otherwise it is a irregular polyhedra. So for example, let us consider a solid. This one is a tetrahedron. It is bounded with 4 equilateral triangle, and the cube, it is bounded with 6 square faces. Then octahedron, a solid bounded with 8 equilateral triangle. What is prism? A prism is having a solid with 2 bases and bounded with rectangular faces. So from the top figure we can understand it is the triangular prism having top base, bottom base, vertical edge, base edge, face, and an imaginary line connecting top and bottom face centers. There is imaginary line connecting these two centers called axis. So based on the shape of the base, we can define different types of prisms, that is square prism, triangular prism, pentagonal prism, hexagonal prism, octagonal prism. Depending upon the number of faces, we can define different polygons. Based on the shape of the polygon, we can define the prism. So by defining prism, a polyhedron formed with 2 equal parallel regular polygon, end faces connected by side faces which are either rectangles or parallelogram. So the figure shows the different types of prisms. First one is triangular prism, next one is square prism, pentagonal prism, hexagonal prism, rectangular prism, and oblique prism. What is oblique prism? In regular prisms, the axis is perpendicular to the base and parallel to the rectangular faces. But in oblique prism, the axis is inclined to the base and the rectangular faces also inclined to the axis, inclined to the base. So let us go through some of the terminology important for the studies. Terminology related to prism. Okay, so here consider a prism consists of 2 bases. One is top base and another one is bottom base. It is connected with rectangular faces. So a vertical line connecting 2 rectangular faces called vertical edge. A horizontal line which connects 2 base edges called bottom base edge, and the rectangular face is called face, and one of the base edges, 2 base edges connecting a corner, that is a base corner. If it is in the top base, it is top base corner. If it is in the bottom base, it is bottom base corner. A imaginary line connecting the medians of top base and bottom base called axis. So for regular polygon, the axis should be parallel to the rectangular faces and perpendicular to the triangular bases. Next we will consider pyramid. Pyramid is a solid bounded by one base and a number of triangular faces and one vertex. So see the top figure, a triangular pyramid. It is consists of a triangular base and a vertex or apex, and the slant edges, a line connecting the apex and the base corner called slant edge, and the triangular faces are called slant faces, and a straight line connecting all the three base edges called base edges, and a imaginary line connecting the median of the base and vertex or apex is called axis. So depending upon the shape of the base, we can define different types of pyramids. If the base is square, the pyramid is called square pyramid. If the base is pentagonal, and the pyramid formed is pentagonal pyramid. If the base is hexagon, and the pyramid formed is hexagonal pyramid. So here you can see the 3D image of some of the pyramids. First one is triangular pyramid, then square pyramid, rectangular pyramid, pentagonal pyramid, hexagonal pyramid, then oblique pyramid. What is a regular pyramid and what is an oblique pyramid? The regular pyramid, all the base edges are equal in length and all the included angle are equal, and for oblique pyramid the angles are not equal. Terminology of pyramid. So a pyramid consists of a triangular base, a vertex or apex, a slant edge, the straight line connecting the apex and the base corner is called slant edge, and the triangular face connecting vertex and one base edge is called slant face, and the triangular shape under consideration is a base, and the edges connecting the base is called base edge. Then the other forms of solids, that is called solids of revolution. The cylinder, cone and sphere, these are all the solids comes under solids of revolution. Why it is called solids of revolution? Consider the first figure, cylinder. We can consider the axis, a vertical line passing through the top base center and bottom base center called axis, and a rectangle formed by this axis. When keeping the axis fixed and the rectangle is rotated, it will generate a cylinder. So cylinder is a solid of revolution generated by a rectangle rotating about one of the fixed vertical axis. So the terminology, the top circle, that is called top base, the bottom circle, bottom base, and the imaginary line passing through the center of the top base and bottom base is called axis, and any curve around the surface called curved surface, and a line connecting top circle, top base and bottom base called generator. And when you consider the cone consists of a circular base and one vertex or apex. The lines connecting the apex and base circles are called generators, and the bottom circle is base, upper corner is called apex, and the axis, the line, imaginary line connecting the base center and apex is called axis. And how the cone is formed? Consider a triangle with a vertical edge fixed, and this triangle is rotated about the fixed diameter. It will generate a cone. So cone is a solid of revolution. Similarly, for sphere, consider the axis or diameter of a circle, and consider a semicircle, and over the diameter, when it is revolved, it will generate a sphere. So the sphere is considered as a solids of revolution. Then frustum of solids. What are frustum of solid? In some of the engineering applications, a regular prism or regular pyramid is used. Sometimes some part of the frustum, some part of the solid is removed and the remaining part is considered as a product. So in such a cases, what is called frustum? So when you consider a prism like a square prism or a cylinder, when some portion of the pyramid, is cut and removed by parallel to the base or perpendicular to the axis, the top portion is removed and the remaining portion is called frustum of pyramid. We consider a square pyramid here. The top portion is removed, cutting the pyramid parallel to the base and perpendicular to the axis. Similarly, when a cone is cut by a plane parallel to the base or perpendicular to the axis through some point, and the top portion is removed and the remaining portion is called frustum of cone. So based on the shape of the base, the prisms can be triangular prism, square prism, pentagonal prism, hexagonal prism, and pyramid can be classified as based on the base, triangular pyramid, square pyramid, pentagonal pyramid, and hexagonal pyramid. So now let us consider the projection of solids with the different positions. Position means we consider the one quadrant covered with one vertical plane, one horizontal plane, and profile plane. We consider the object, maybe for example a cylinder is placed above horizontal plane and in front of the vertical plane. So the observer is viewing this arrow direction, and we consider a simple position. Simple position means the base of the cylinder is parallel to HV or parallel to vertical plane or parallel to profile plane. The other way, the axis is perpendicular to HV, horizontal plane. The axis is perpendicular to VP or vertical plane, or the axis of the solid is perpendicular to profile plane. So these are all the three different possible conditions of a solid in simple positions. Okay. So let us consider some example. So example 1 means a triangular prism, 40 mm side of base and 60 mm length of axis perpendicular to the VP. Draw the projections if one of the rectangular faces is parallel to the HV and 20 mm above the HV. So before starting the solution, we have to understand and read the problem once again, try to understand what are all the data. Here the object is triangular prism. So the object triangular prism is given underline because to while starting the drawing or the projections of the prism, you should understand what are the terminology related to triangular prism. So triangular prism is consists of two triangular bases and three rectangular faces and base edges, vertical edges, corners and axis. So here the dimension given are 40 mm side of base. So the one of the base edge size is 40 mm and axis length, height of the prism is 60 mm. And the condition given is the axis perpendicular to the VP. Axis perpendicular to the VP. So this one we have to understand very clearly. So the conditions given, the axis perpendicular to the VP, draw the projections if one of the rectangular faces parallel to the HB and 20 mm above the HB. So if you don't understand the problem clearly, it will be very tough to draw the projections. So first we have to understand what is the object. So the object is triangular prism. So what is the length of the base? The length of the base is 40 mm. And what is the length of the axis? The length of the axis is 60 mm. Here with reference to axis, whether the axis is parallel to HB or perpendicular to HB. So in this problem, the axis is perpendicular to the VP. So let us see the next figure. The object is triangular prism. When the axis is perpendicular to VP, so you have to imagine the position of the object is, or the triangular prism is like this. So here we consider vertical plane, horizontal plane, profile plane, and it is in the first quadrant, and the base, one of the base is away from VP, and from the HB, horizontal plane, the one of the rectangular face is 20 mm above. So since the axis is perpendicular to VP, and we can see the true shape of the one of the base in front view. So in which view, front view or top view, we can start the true shape of the base. So this is the true shape of the base in the second figure above XY. It is represented with the A dash, B dash, C dash. So the A dash, B dash, C dash represent the front view or the true shape of the triangular prism in the front view. So since the axis is perpendicular to VP, we have to assume that the true shape of the base is available in the front view. So we have to start the triangular face, triangle in the front view. So draw the line XY, reference line. Above the reference line XY, we will consider front view. Below the reference line XY, we consider top view. So the object is 20 mm above the horizontal plane. So above 20 mm above XY, draw the baseline. It is 40 mm length, and complete the front view by usual geometrical construction. Then for the front face, you can name A dash, B dash, C dash. The rear side you can consider A1 dash, B1 dash, and C1 dash. So now the front view is completed. Now project A dash, B dash, and C dash vertically downwards, and start the base. And the length of the axis is 60 mm. Through the axis, draw a vertical line 60 mm, and by projecting A dash and B dash, we can understand the width of the prism in top view. So complete the A1, B1, then projecting 60 mm. Here in the front side, you can take A, B. And for top view, you can see A dash, A1 dash as a straight line. In the top view, B dash, B1 dash you can see as a straight line. Also for the C dash, C1 dash you can see as a straight line. So now the front view looks like a triangle having 40 mm base edge, and the bottom edge is parallel to XY and 20 mm above XY, since the rectangular face is 20 mm above HB. And the top view, it looks like two combination of two rectangles and 60 mm length, and the width is equal to the top view, that is 40 mm. Clear? So let us take another example. A square prism, 40 mm side of base and 60 mm length of axis, has its axis perpendicular to the HB. Draw the projections if one of the rectangular faces is parallel to VP and 10 mm above the HB. Here also once again go through the problem. What is the object? Here the object is a square prism. Square prism means the base is a square and each side 40 mm and axis height is 60 mm and the axis perpendicular to the HB. So the axis perpendicular to HB, then you have to, in the top view only, the true shape of the base is available. The top view only, the true shape of the base is available. So we have to start with the top view. For square prism, the base is a square and in the top view, the true shape is available. So let us understand, we have to start with the top view, and while drawing the top view, another condition, draw the projections if one of the rectangular faces is parallel to the VP and 10 mm above the HB. For rectangular face, one of the rectangular face parallel to VP and 10 mm above the HB. So let us go to the next solution figure. So here you have to understand the real position of the square prism as per the given condition. The side is 40 mm, the axis height 60 mm, and the rectangular face, one of the rectangular face is parallel to VP and the base and 10 mm above HB. So the solid is 10 mm above HB and parallel to vertical plane. So here the axis, since the axis is perpendicular to HB, we can see the true shape of the base in top view only. So draw the top view first. So draw the line XY, and while drawing this top view, here the position of the object from vertical plane is not given, but it is given that it is parallel to VP. So since the rectangular face is parallel to VP, in top view, one of the edge is parallel to XY. It is the understanding. So giving some distance from XY, draw the line parallel to XY of 40 mm base, and complete the rectangle, complete the square, since the top view of the square prism looks like a square in the top view. So this is the first step we have to complete. Draw the square in top view below XY, leaving some distance 10 or 20 mm below XY and parallel to XY, to take 20 mm and complete the square. Now in the top view here, in the left side figure, you can, the name of the top base is given as A, B, C, D. Capital A, capital B, capital C, capital D. And when the prism is viewed from above, always the top view projections are mentioned in lowercase letter and front view projections are mentioned in lowercase letter with dash. So here small a, small b, small c, small d for the top base. The bottom base is invisible. For that we are assigning name A1, B1, C1, D1. So even though the top view of the given prism looks like a single square, but it represents two bases. One is top base and another one is bottom base. The top base is represented by A, B, C, D, small letter or lowercase letter without dash, and bottom base is invisible from viewing from above, and it is represented with the lowercase letter A1, B1, C1, D1. Okay. Now for drawing the front view, project all the A, B, C and D vertically upwards up to XY, reference line XY. Then the solid is 10 mm above HB, or the rectangular face is 10 mm above HB. So take a horizontal line 10 mm above XY, and from the projected line from A, B, C and D, take a height of 60 mm to complete the front view. So see the left side figure, when it is viewed from front, it looks like a rectangle. So for this rectangle, the name given is top edge capital A, capital B, bottom it is B1, A1, B1, capital A1, B1. Similarly, back side it is C1, D1 for the bottom base. So in the front view we can see only this rectangle A, B, A1, B1. So for representing this front view we consider A dash, B dash, A1 dash, B1 dash. So this is the front face. So also we have another face, rear face, C, D, C1, D1. So we consider C dash, D dash, C1 dash, D1 dash. Even though it looks like a single rectangle, it represents two rectangles. One is A dash, B dash, A1 dash, B1 dash. Another one is A dash, B dash, A1 dash, B1 dash. Rear side it is C dash, D dash, C1 dash, D1 dash. I think it is clear. Let us consider the another example. Draw the projections of a cylinder, base 40 mm diameter and axis 50 mm long, and another problem, a cone of base 40 mm diameter and axis 50 mm long, resting on horizontal plane on their respective bases. So here once again let us consider in the same problem we are given two objects. One is for the first section it is a cylinder of 40 mm diameter and axis height of 50 mm, and for the second problem it is same dimension 40 mm diameter and axis 50 mm, but the object is cone, and both the condition the base is resting on horizontal plane. So for this we have to draw the front view and the top view. So for the first one the object is considered cylinder. For cylinder in the front view, since the axis is okay, the base is resting on horizontal plane. Since the base is resting on horizontal plane, the true shape of the base should be drawn first. So while considering true shape of the base, in top view only the true shape of the base is available. So first imagine that the object is like this. In the top view only the true shape of the base is available, so that we have to start with the true shape of the base in top view as a circle. So the position is not given. Let us consider draw the reference line xy, and below the xy locate a point for the axis top O. Then for the given diameter of 40 mm, draw the circle, and for understanding we can give the name here A, capital B, capital C and capital D, and these are all the four quadrant points, and O is the center of the top base circle. For bottom, so in the top view we can give the name A, B, C and D for the center point O. So since it is a cylinder is a simple object, dividing the circle into 4 is enough. So now project all the points A, B, C and D upwards up to xy. Since the cylinder is resting on the horizontal plane with the base, the bottom end of the base is looking like a horizontal line, and draw the horizontal line for the diameter of the circle, and the height of the cylinder is 60 mm. So draw a line 60 mm projecting the axis and complete the rectangle as for the front view. So the front view of the cylinder, even though the object is cylinder, when it is viewed from its front, it looks like a rectangle. So this is the front view and this is the top view. And if you consider the same dimension 40 mm base and 60 mm axis for a cone. For the cone, the top view is a circle. Okay. If you consider a cone resting on the base on HB, its axis becomes perpendicular to HB and parallel to VP. Instead of cylinder, if you consider a cone, and the true shape of the cone is available in the top view only. So draw the top view of the cone as circle of given diameter and give the name for the base quadrants 1 dash 2 dash 3 dash lowercase letter 1 2 3 and 4, the vertex O. Now the horizontal diameter 1 3 can be projected upwards along the line XY to get the base in front view. Now project the axis for the given height of 60 millimeter, then join the vertex O dash with 1 dash and 3 dash. Now the front view of the cone looks like a triangle in the front view. Let us go for another example. A hexagonal prism has one of its rectangular faces parallel to HB. Its axis is perpendicular to VP and 3.5 cm above the ground. It is having base side is 30 mm and height is 60 mm. So once again you go through the problem. First find out the what is the object, whether it is a prism or pyramid. Then how many edges it is having. Since it is a hexagonal prism, it consists of hexagonal bases and 6 rectangular faces. Then next the position given. The dimensions are 3.5. The 3.5 centimeter above the ground. Don't confuse with the centimeter and millimeter. 3.5 centimeter means 35 millimeter above the ground. Which one? Its axis is perpendicular to the VP and 3.5 centimeter above the ground. So let us consider the base point is 3.5 centimeter above the XY. And for a hexagonal prism, what is the true shape of the base? A hexagon. So in which view, front view or top view, the hexagonal true shape of the hexagon is available. Here the rectangular faces parallel to HB. The axis perpendicular to VP. The axis perpendicular to VP means it is parallel to HB. So the front view shows the true shape of the base. So consider this figure. The hexagonal prism. Since the axis is perpendicular to VP, the true shape of the base hexagon is available in front view. So we have to start with the front view. Let us consider a reference line XY. The axis is perpendicular to the VP and so draw the reference line XY and draw the front view A dash, B dash, C dash, D dash, A dash, B dash, C dash, D dash, E dash, F dash for the front face, and the rear base it is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. For the center we can consider O dash. Since it is 20 mm axis is that 3.5 centimeter above XY. So first above XY above xy locate O dash 3.5 centimeter or 35 millimeter. Then based on that you complete the front view. Since the rectangular face resting on parallel to HP. Rectangular faces parallel to HP. Now project A dash, B dash, C dash, D dash, C dash and D dash vertically downwards to XY and project further. And the distance from the vertical plane is not given. So assume 10 or 20 millimeter from the XY, and the line the base is parallel to vertical plane. Since the axis is perpendicular to VP, the back or rear base is parallel to VP. So parallel to XY, complete the one edge projected from front view. Then the axis length is given. For that length you complete the top view. So the front view looks like a hexagon, and the top view looks like a combination of three rectangles with a axis. Another example, a triangular prism, 40 mm side of base and 60 mm length of axis perpendicular to the VP. Draw the projections if one of the rectangular faces is inclined at 45 degree to the HV. So here, understanding the problem, what is the solid, prism or pyramid, then what is the position, the axis inclined to VP or axis perpendicular to VP or perpendicular to HB, which view shows the true shape of the base is an important task. So here the object is triangular prism. In triangular prism, what are the terminology, what are the components we have? In triangular prism, we have two triangular bases and three rectangular faces. And dimensions are 40 mm and 60 mm. 40 mm is the side of base and 60 mm is the axis length. Here the axis is perpendicular to the VP. Since the axis is perpendicular to VP, the base will be parallel to, the length of the axis perpendicular to the VP. Draw the projections if one of the rectangular faces inclined at 45 degree to the HV. Here not the axis, here also don't confuse with this angle. Here the axis is not given, inclination with the HV. What is given? The rectangular face is, so when you go to the next solution problem, here is the actual given position. Based on the problem given, you have to understand all the data and you have to imagine the position of the triangular prism in the given position. Here the triangular face, the rectangular face is given as 45 degree with the horizontal plane. So this one you have to understand. Okay. So not the axis. Here the axis is perpendicular to the VP. Since the axis is perpendicular to VP, the base is visible in the front view as true shape. The true shape of the base triangle is available in the front view. So let us understand, we have to start with the front view. So while drawing the front view, draw the reference line XY and draw a horizontal line. Consider a corner of the base here, and since one of the rectangular face is 45 degree with the HB, draw a make an angle of 45 degree and draw this line, and this is the base edge, and complete the triangle for 40 mm base edge. So while doing so, this edge, that is small a, b, a dash, b dash, make a 45 degree, and adjoining the rectangular face a dash, b dash, a1 dash, b1 dash, that rectangle makes 45 degree with the horizontal, means 45 degree with the XY in front view. Okay. So now the triangle is front view is covered. So this is a very the problem looks like a very simple and easy, and understanding in which view, the front view, the true shape of the base is available, and how to start with the first edge is very important. Here we are drawing XY reference line, and we are starting, we can draw the front view triangle A dash, B dash, C dash, and locating A dash at some distance above XY. It is assumed that the longer edge A dash A1 dash is some 10 millimeter above horizontal plane for clarity. So 10 millimeter above XY, locate A dash, and since the angular one of the rectangular face is making 45 degree with the HB, we have to understand that the rectangular face, this base edge covering the rectangular face A dash A1 dash, B dash B1 dash is 45 degree with the horizontal plane, and also inclined 45 degree with the XY. So from A dash, make 45 degree with the horizontal and draw this base edge, then complete the triangle. Now the front view is over. Now projecting A dash, B dash and C dash vertically downwards. Now complete the top view. Here C dash C1 dash looks like a straight line, B dash B1 dash looks like a straight line. Now see, consider another component here. When it is viewed above this object, the straight line C dash C1 dash is visible, the line B dash B1 dash is visible, but A dash A1 dash is not visible. So the invisible edge A dash A1 dash is shown like a hidden line or line in the top view. So in the top view it looks like a rectangle with the bottom edge is not visible. It is represented with the hidden line. Okay. Another example, a square prism 40 mm side of base and 60 mm length of axis has its axis perpendicular to the HV. Draw the projections if one of the rectangular faces is at 60 degree to the VP and 10 mm above the HV. What is the object here? It's a square prism. What is the size? Base side 40 mm. What is the axis height? 60 mm. What is the inclination of the axis? It is the axis perpendicular to the HB. The axis perpendicular to HB means base is parallel to HB, or see the solution. This square prism axis perpendicular to HB. So in the top view only the true shape of the base is visible. We have to understand that we have to draw this top view first. So draw the reference line XY, then draw the top view. While drawing the top view, one condition you have to satisfy, that is, draw the projections if one of the rectangular faces is at 60 degree to the VP and 10 mm above the HP. 10 mm above the HP. So 10 mm above HB is visible in the front view. Let us not worry about that. And one of the rectangular faces, 60 degree with the VP. So any angle with the VP is visible in the top view only. So first, while drawing this first edge of the top view, here consider after completing the reference line XY, making 60 degree, draw a line. On that line, take the first edge. Here it is CB, and with reference to that edge, complete the square of 40 mm side. Okay. Now the top view represent the top base A, B, C, D, and bottom base A1, B1, C1, D1. So what you have to understand here is, the object is square prism and the dimensions are base edge 40 mm and axis height 60 mm, and the condition is the axis perpendicular to HB. If the axis is perpendicular to HB means you have to imagine the shape or position of the square prism as given in the figure, and so that the true shape of the base is visible in the top view. We have to start with the top view, and in top view we can see only a square, and while drawing the square, drawing the first edge is very important. So to draw the first edge, what is given in the problem, it is one of the rectangular faces making 60 degree with the VP. So any angle or any inclination with the VP is seen in top view. So while drawing the first edge of the top view square, make a 60 degree angle and draw a line from XY. On that line XY, take one edge like BC. Okay. Then with the reference to this BC and making perpendiculars, complete the square in top view. So that you can assign names here: a, small b, small c, small d for the top base, and for the bottom base it can be A1, B1, C1, D1, and also mark the angle 60 degree, that is with the XY. The 60 degree with the XY is the side of the, that is a rectangular face making 60 degree with the that is VP, vertical plane. Now to complete the front view, from A, B, C, D in the top view, project up to XY and project vertically upwards. Here the base of the, it is given that in the problem, the one of the rectangular faces 60 degree to the VP and 10 mm above the HB. So while drawing above the HB means it is seen in the front view. So from XY take 10 mm and draw the horizontal line, and in between the left extreme end and the right extreme end of the projectors. Here D is the left extreme end of the front top view, and B is the right extreme end of the top view. In between projectors from small D and small a, complete the baseline above 10 mm, that is the bottom base in front view, and the height of the prism is given as 60 mm. So from all the corners of the base, draw vertical lines for 60 mm and complete the front view. So if it is viewed from front, listen here, from A1 visible. So A1 dash is straight line. When viewed from front, B1 is visible. So projecting B1 dash is straight line. And here viewing from front, D1 is visible. So D1 dash is visible straight line. And when it is viewed from front, so C1 is hidden or invisible. So projection from this line is drawn with a hidden line. So C1 dash is a hidden line. Okay. And by projecting the center of the top view, and you can draw the axis in the front view also. Now the front view and the top view of the given square prism is over. Okay. Next problem, a triangular pyramid. A triangular pyramid with 30 mm edges at its base and 35 mm long axis resting on its base with an edge of the base near the VP, parallel to and 20 mm from the VP. Draw the projections of the pyramid if the base is 20 mm above the HB. What is the object in this problem? Triangular pyramid. So for pyramid, first understand whether it is a prism or pyramid. Then which type of pyramid or prism. Here the object is pyramid. Pyramid is consists of one base and one vertex and number of triangular faces. So that imagination you should have immediately after reading the object. So it is a triangular pyramid. So a triangular base and one vertex and 3 triangular faces consist of this triangular pyramid, and dimensions are the base edge 30 mm and axis height 35 mm. So these are all the conditions for problem. Then condition, how it is located or placed in the space, and base, one of its base with an edge of the base near the VP. The base which is near the VP parallel to and 20 mm above the VP. Parallel to parallel to and 20 mm from the VP. One base edge is parallel to VP, so it is parallel to XY in top view, and 20 mm away from VP, that is 20 mm from XY in top view. So here object is a triangular pyramid. What is the condition given? Draw the projections of the pyramid if the base is 20 mm above the HB. Base is 20 mm above the HB. Base is 20 mm above the HB. The axis is not given. So let us understand that the axis is perpendicular to HB and base is parallel to HB. Since the base is parallel to HB and axis must be, so since the base is parallel to HB and axis is perpendicular to HB, the top view only show the true shape of the base. So the true shape of the base is a triangle with vertex and 3 slant edges. So first we have to understand that we have to draw the top view, that is true shape of the base, and while drawing the top view, draw the line XY, and here one of the base is the base near to vertical plane. In top view near to XY, the first edge is parallel to XY or parallel to VP and 20 mm in front of VP or near to VP. So from XY take 20 mm and draw a line parallel to XY, that is base edge AB. Then with a reference to AB complete ABC. Then draw the intersection of the medians and locate the point O, that is the vertex. Now join vertex O with A, then B, then C. A combination of triangle, then three slant edges and one vertex combinedly give the top view of the given problem. Now the base is 20 mm above HB. So now from the top view A, B and C project vertical lines up to XY, then further project upwards. Since the base is 20 mm above HB, so 20 mm, any distance above HB is seen in the front view. So above XY take 20 and draw the baseline between the left extreme A and right extreme B of the top view. So A dash B dash is the front view width. Now locate the C dash projecting C. Now the base is over. From the C dash take the height of the pyramid 35 mm and locate the vertex O dash. Now join O dash with the A dash, O dash with the B dash and O dash with the C dash. Okay. So to locate the vertex, V dash is given here. So now the projection of top view and front view is over for this problem. Okay, let me stop this presentation at this stage. I will continue in the next video. Thank you, and thank you all the viewers. If you have any queries, we will meet in some occasion and we will clear it. Thank you one and all.